So how's things, Ezra?
Things are good. Yeah.
Good. There. So what we got here? There's River coming in. Can you hear me okay, Andre? Good. Can you hear me okay, River?
Yeah, I can hear you good.
Good. Well, we still have, what, 10 minutes before we officially start. Any general questions that you want to get off your chest? Well, I guess that's a good sign. Homework going okay for everyone? Quite a lot tonight, or this evening. Has anybody got a really bad joke for me? No, that's a good way to start the day. Ezra, you got a bad joke?
Not that I can think of.
Okay. What about you, Andrew? River, got a joke?
I do have a joke.
Is it suitable? That's the only rule. It has to be suitable.
Like appropriate?
Yes.
Yeah.
Okay, go for it. What's your joke?
Two guys walk into a bar and they both say, ouch.
You would think one of them would have seen it. Ezra's shaking his head. You can't. Well, maybe you can't see it. I don't know. It wasn't that bad. That was a good joke. Did I tell you the one about what do you do if you get attacked by a group of circus performers?
No, I haven't heard that.
I
No,
don't think so.
no. You go for the juggler first.
What?
Jugular vein, juggler.
Oh.
Oh God, that was a bad one. If I have to explain it, it's a bad one.
Quite dark, but yeah.
Yeah, well, a lot of Scottish humour is dark. It's just, I don't know, it's to do with the fact we're so far north that we have issues with morbidity or something. Yeah. Well, if you're into dark humour, then you probably will enjoy Scottish jokes. If not, then you probably won't. See another one. Do you hear about the two? This is another dark one then. Did you hear about the two Scottish guys were in a bar drinking? And one turns around to the other and says, "What are you going to buy your wife for Christmas?" And he says, "I'm buying her nothing." And his friend looks at him and says, "Oh, come on, you've got to buy her something." He says, "No, I'm not buying her anything. She never used the gift I bought her last year." And his friend said, "Yeah, but that was a coffin."
Oh my God.
Right. I think we need to move this uphill then, because obviously they're far too depressing for you. What kind of humorous jokes do Scottish people have that aren't involving people getting killed? Not many, actually, I can think of. Someone's got to get hurt or killed in most of the jokes. I'm trying to think of one where neither of those two things happen. Okay, here's one. How do you stop a Polish tank?
I don't know.
Shoot the people pushing it. Are these jokes that painful, Ezra? Every time I tell a joke, oh, Andrew liked it. Anytime you tell a joke, I can't tell if it's painful or you like it.
I'm laughing, also reading
Oh, okay.
book. So I'm just I just go.
You're doing you're multitasking. That's well done. Did you hear about the Canadian guy who got killed raking up the leaves? He fell out the tree. Emily, we're telling really bad jokes, or I am for the most part. Have you got a bad joke to add to our list? I don't know if Emily has no joke to tell me or she can't hear the question. Any jokes for us, Emily? Evidently, we're having communication issues with her. Hi, Tiara. You make it? Can you hear us?
Yeah.
Good. Have you got any really bad jokes for us?
At the moment.
Okay. Maybe in the future.
Yeah.
Yeah. I'm still trying to find of jokes that don't involve someone getting hurt or killed, and it just shows you my list is quite small. Okay, what did the little chimney say to the big chimney?
What?
You're too young to be smoking. No? No, at least nobody get killed. Yep, that's all I got. Well, we've still got a few more minutes, and maybe someone who's just joined has got a general question they'd like answered before we get started. Still got 4 minutes, so here we go.
So you know how I broke my computer last
Yes,
week? That was a hassle and a half.
I can imagine. It wouldn't be fun.
I cried so hard.
Oh dear.
But I got a new and better one.
Okay, that's good. So things worked out in the end for you.
Yeah.
So have you managed to catch up yet?
I'm pretty sure I have.
Good.
Not with my other classes though.
You're still a little bit behind in your other classes, is that what you're saying?
Yeah.
Well, hopefully you've still got a few weeks before we end of the quarter, so a bit of luck, you'll have time to get them up to where they should be.
Yeah.
Yeah. This particular chapter that we're doing right now is the algebra of trig. And if you like algebra, then I guess it's not too bad, but it's not very practical. It's not like finding the length of something or the height of something or whatever. And I think that kind of makes it difficult for people. It's a little bit easier if it's a triangle and you're trying to find the third side. At least you know that the answer's a number and it should make some kind of sense. But when you're looking at the prove this identity or simplify this trig expression or find the exact value of some weird angle, those type of questions don't really make as much sense in real life as it would the other stuff we've done. So if you're having extra trouble with that, I can understand why. It's not something that comes easily, but it does eventually. It does come out. If you hang in there and work through it, you begin to see there's processes that you can use and things that you can do to kind of make that a little bit easier. Right. So it looks like we're almost at our starting time. I'm just getting a few people who are trying to get in set up before we begin. Looks like Olivia is having issues getting in. Nope, you made it. I'm assuming you made it, Olivia. You're through. Not sure if she did make it, actually, no. Yeah, she's in my list. So, Olivia, it says that you're here. Can you hear me? That's not good. If you can at least hear me, you can use the chat and just type in yes, and we'll call it good. Oh, there we go. Yeah. Okay, some of you are doing it through text, and that's fine. I understand that.
Is it okay if I ask you a question?
Sure. What do you want to ask?
So 2 weeks ago, we had a Zoom meeting as a whole class,
Yeah.
and you explained how to find the sign of a whole number. And I can't find my notes for that anywhere.
I'm not sure.
Like sign of 5 in radians.
Oh, yeah. That question had a big circle in it with numbers around it as well, didn't it? If I recollect right.
I don't know for sure. Are you talking about the unit circle?
Yes. Yeah, I don't have that particular thing handy. The easiest way to do that is if you could just, well, I could try showing you. I'm not sure how convincing I'm going to be because I really need the real picture with real numbers on it. But essentially, can you imagine a unit circle, right? But instead of having the normal numbers, you know, like pi upon 2 and so on, they have things like this.
Yeah.
Right? And then if you, I know this is definitely not accurate, but imagine you were being asked to find the sign of 4.
Mhm.
So you imagine the line going to the 4, and then this number here, let's say that it's 0.9, negative 0.9, and this number over here, let's say it's 0.2, just for argument's sake. So you try the best you can to judge that. Now, isn't the sign the y-coordinate?
Mhm.
And if the y-coordinate in here is 0.2, it means the sine of 4 would be 0.2. So that's kind of how you do those. So you look at the outside of the big circle, you find the number 5, the x-coordinate will be the cosine of 5, and the y-coordinate of that guy will be the sine of 5.
Okay.
Okay. Now you're going to do a bit of judgment call because you're going to look at a dot and you're going to say, is it 0.8 or is it 0.9? So you make your best guess, right? You're not going to be perfect because you can't be in a situation which involves estimating.
Okay. Thank you.
You are welcome. It looks like we're almost everybody who's going to come has arrived. Maybe a couple of stragglers at the end. But I'm going to do something for a few seconds. I found a much quicker way to figure out who is here. I just do a screen capture of all of you, and then I just keep the screen capture. That way I know who is here. I don't need to write them down and then try and remember where I put the piece of paper. So that's where we are. Are you looking right now at the big picture of this paper here? Right, okay.
Yep.
So what we're going to do today is look at the other two sections. I think we've spent as much time as we can afford to on the identity stuff, and now we're going to move on to the add and subtract and the double and half angle stuff, because there's a lot of work in them as well. And I want to at least cover some of that stuff before this week is over. So let me check. Okay, we're ready. I'm now going to show you a thing that's going to be of some use to you, I hope. Let's see where we are. Here we go. So I'm sharing right now the Canvas page, one of the 142 Canvas page. And do you notice this guy here that says 142 trig formula? Right, when I click on that, eventually, do you see the trig formula that I can see, or do I have to go back in it? I'm scrolling it right now. Can you see big red writing, trig formula, and then some stuff?
Yeah.
Yep.
Okay, perfect. So all I'm going to do is say, this is here for you. Essentially, to do these questions and definitely to do the identities, you're going to refer to some or all of these things at least somewhere in the 3 sections that you've got in your homework. And what I've done is I've just put them all in one place. So if you want to, you can go here and maybe print it out and have it as a piece of paper at your side, so that when you need to, I can't quite remember what the cosine of x minus y is, which you probably can't, nobody does. That's what it is, right? And you can use it. Right? And these are called the double angle formula. These are the addition and subtraction formula, for instance, and these are called the half angle formula. So today we're going to spend our time doing questions that almost all of them are going to use one of these 3 particular things. So let me close this off. And add Conrad. Oh, okay. Almost got my thing right. Here we go. No, I've got an idea. Has anyone got a homework question they want to go over? I've got some I want to do, but I'd rather do ones that you found difficult first, and then I can fill in the gaps. Has anyone got a specific homework question that they were having trouble with? Okay. Here's an example of the addition subtraction issue. The question will say something like, find the exact value of the sine of 15 degrees. Now that is important, the word exact value. In fact, virtually none of the questions that you've been doing lately do you ever write down 1.234. It's always going to be root 7 plus 3 over 2. It's going to be exact values. They might look pretty messy, but that's what they want. Now you can't get the exact value of sine of 15 from your unit circle because it ain't there. Right, the first guy you get after 0 is 30. Right? What you're expected to do is to use the add subtract trick. So you are going to look for two angles that add or subtract to give you 15. It's pretty obvious this is going to be a subtraction, right? So you're going to have an angle, take away another one that equals 15. And before you jump right in, you're going to say, oh, there's tons of them. I could do 70, take away 55, right? I could do 90, take away 75, right? I could do all sorts of things, right? But you must choose two angles that are already in the unit circle. And so that does restrict your choices by quite a lot. Now, if you imagine your unit circle, you've got, for instance, 30, 45, 60, you've got 90 if you move over here, you've got 120, you've got 135, finally you've got 180. So, I mean, there's plenty to choose from. Can anyone tell me two angles that you subtract that gives you 15?
60 minus 45.
60, take away 45. Agreed? You agree that's 15. That is correct, and if you use it, you get the correct answer, and that's the one I would have picked. But sometimes, just sometimes, not always, you can get more than one way of doing it. And that's the one I would choose, but can anybody see another combination that would do the same job? Two angles subtracted that give you 15.
45 and 30.
Okay. 135 and 20. Yeah, right. So you might say, well, which one's the right one? The answer is they're all right. So I don't care. Right? It's okay. As long as they come to 15, use it. But you might think, oh, wait a minute, I'm going to get different answers. No, you won't. You'll get the exact same answer every time. That's why it doesn't matter. Now we come into phase 2. So phase 1 is find two angles that subtract, in this case, to give you 15. Fair enough. And now I'm going to look at whoops, there we go. The sine of S take away T. And the reason I'm choosing that one is because this is going to be S take away, this is going to be T. And when I look up that formula sheet that's in Canvas, I will find a version of that. And it will say, might not use the letters S and T, but that doesn't matter. It'll say the correct thing. It will say sine S cosine T, take away cosine S sine of T, which means that I now have the sine of 60 degrees multiplied by the cosine of 45 degrees, subtract the cosine of 60 degrees times the sine of 45 degrees. Now, every one of these four pieces, sines and cosines included, aren't they all numbers that you can get from the unit circle? Right? We can find the sine of 60. We can find the cosine of 45. I'm picking that one because it's the easy one. Take away, we can find the cosine of 60, and we can find the sine of 45, which also happens to be that guy. So I'm going to give the challenge to you lot. The sine of 60 degrees, isn't that the y coordinate of this guy here? Right, it's the y coordinate. What is, so what is it?
3/2.
Thank you. And what's the cosine of 60 going to be? Won't it be the x coordinate at that point? And that happens to be half. Now, I've got root 3 times root 2, which is what, root 6, and 2 times 2 is 4, so that's what that guy gets you. And a 1 times root 2 is root 2, and 2 times 2 is 4, which is what that guy gives me. And then you put them together, and that's the thing that goes in the box when it says, find the exact value of the sine of 15 degrees.
Oh yeah, can you move over the paper slightly? It's slightly out of camera.
Okay, thank you.
Yeah.
I didn't know that.
There
help?
we go. Thank you.
Right, I'll try and keep it there. And are we comfortable with that process? Find two numbers that subtract to give me 15. Find the right formula for, in this case, the sine of s take away t. Plug in the numbers, make it look pretty.
Yeah.
Right. So that's how you're doing. Do you know those questions that say, give me the exact value of the cosine of 75 degrees, or give me the exact value of 220 degrees, or whatever it is, right? Those kind of questions. You're going to do it by this process. Now I'm going to do the same question again, but this time with radians. And that can be a little bit more awkward just because the numbers that radians use aren't as simple. So suppose you were being asked to find the cosine of 5/12 pi. Now that is not in your unit circle. I mean, if you think of your unit circle again, the first guy you get is pi over 6. Then you get a quarter pi. And then you get a third pi. And then over here it's 2/3 pi. And then it's 3/4 pi. And over here it's what, 5/6 pi, right? And all the other guys, right? Which is why it's probably a good idea just to have a printout of a nice big unit circle in front of you as you scan through these. Nah. Some of you might just be able to do this, and it's great if you can. Some of you can just look at these and say, oh, that guy plus that guy gets me 5/12. Or this guy take away that guy gets me 5/12, right? That's what you're looking for. Two angles that add up to give you 5/12 pi, or two angles, if you subtract one from the other, you get 5/12 pi. But if you're finding that difficult, which typically it is, a little trick is to turn them all into 12ths. Because if every single angle is in 12th, don't you just need to worry about what the two top numbers are? Right, everything in the bottom is going to be 12, so I don't worry about that now. So what you're really looking for is two guys in this list that you add together and get 5, or you subtract and get 5. And it doesn't matter which one you find, as long as you find one, it's going to work. So that's your puzzle. Can anyone tell me a solution to that puzzle? Two angles that add to give you 5, two angles that subtract to give you 5/12 pi.
Pi over 4 plus pi over 6.
I would agree with that one. Would you agree that these two guys get you 5/12? And I'd use that answer and I'd get the right answer, and that's cool. just for curiosity, is there a subtraction you can find that would do the same job? Because sometimes there is, I'm not saying all the time, but sometimes you can do it. Is there a guy, take away a guy, that gets you 5/12? Can anyone see that? Because there is one. Start with one, take away the other, and you're left with 5.
2/3 pi minus pi over.
So that one, 5, and that one. Agreed? 8/12 take away 3/12. That gets you 5/12. 8/12, as you were saying, is 2/3 pi before I interrupted you. And then take away the other one, 1/4 pi. Right. Now, if I went, say again?
12, just pi. Minus,
Okay.
7/12 pi.
That would be good, except I can't see a 7/12 in a unit circle. Both numbers have to be in the unit circle.
Oh.
And so those ones work because they are. Now, let's do the add one, because that's the first one that was given. That's probably the one I would have came up with if I was just looking at it. Right, there is a formula for this guy. If you call this fella S and you call this guy T, you're really looking for the formula cosine S plus T, which I happen to know is cosine S, cosine T, subtract sine S, sine T. And now we put in the numbers. What have we got? Pi upon 6. So it's going to go the cosine of pi upon 6 times the cosine of pi upon 4. Take away the sine of pi upon 6 times the sine of pi upon 4. Okay, the cosine of pi upon 6 is root 3 upon 2. The cosine of that guy is root 2 upon 2. The sine of pi upon 6 is a half, and the sine of pi upon 4 is root 2 over 2. This first guy gets you root 6. The second one gets you root 2. And would you look at that as a sheer and utter coincidence? It's the same answer as that one. What's it? I mean, I could try that 20 times and I'd be lucky if I ever got that once. Evidently, the sine of 15 degrees is the same thing as the cosine of 5/12 pi. Can't explain why it is. It just happens to be what it is. Okay, now after I've done this question, has that jarred any of you into a homework question, or do you want me to just keep going with what I feel is some of the topics? Are we good? Okay, so this next question is like leaps and bounds ahead of this one. Suppose I tell you that the sine of x is 5/13 and the x is in the second quadrant. And then I go and I tell you that the sine of y is 1/4 and x is in the first quadrant. The cosine of x take away y. So it's another one of these find the exact value, but the one that you're trying to find the exact value for isn't sine or cosine x, it's cosine x take away y, right? It's got a bit of a and a bit of b in it, right? It's a bit of mixture. Now, that question is not a one-liner. It's got a number of steps in it. Let's start off with our first step. If you look up the formula, you call that S, take away t, you'll find that it is the cosine of x, cosine of y, plus Yeah, it's not a mistake. Plus the sine of x, sine of y. I just picked that up from the formula sheet, right? I just looked at the formula for the cosine of two things subtracted, and that's what I would come up with. And when I look at the information that I know, I don't know this guy, and I don't know this guy. I do know that the sine of x is 5/13, and I know that the sine of y is 1/4. So I guess I know that bit. So all I need to do is find out what the exact value for the cosine of x is and what the exact value for the cosine of y is. Put those two fractions there, and then, you know, I'm pretty much done. Well, let's see how you go about that. So let's just put a little separation line here. If I use this fella, and I think back to all the various ways that you can look at the sine of an angle, and I think back to SOHCAHTOA, then won't this fella be the opposite over the hypotenuse? Great. Then I'm going to build a little right angle triangle to help me out. And I'm going to put this little in here, call it x. That's my opposite, that's my adjacent, that's my hypotenuse. In this case, the opposite would be 5, and the hypotenuse would be 13. So you see, I've already got two sides of that right angle triangle created. How do you think I'm going to find the third side, the missing adjacent side?
Staggering.
Yeah. I've kind of cheated and made my life easy. It's a nice answer, right? It's 12. But it's probably going to be the square root of 71 or the square root of 117 or something, right? But whatever it is, it's what it is, right? That's what you use. Now you might say, well, that's great. How's that going to help me? Well, remember what my goal was. I needed to know what cosine x is. Well, if I've got this right angle triangle, isn't the cosine of x the adjacent over the hypotenuse, which makes it 12/13. So that's how I managed to figure out what it was equal to as an exact value. And then a little kink in the tail. Right up here, it said the x is in the second quadrant. And you might think, no biggie, I'm not paying much attention to that. You do actually have to pay attention to it. If you are in the second quadrant, won't the cosine of x be a cosine of an angle in the second quadrant? Is that a positive or negative thing?
Negative.
And that's why that isn't 12/13. That's why that is negative 12/13. So if you've done some of these questions and you weren't getting the right answer, it might simply be you didn't have a negative where you needed one. So I now know that this guy is negative 12/13. Good start. Well, it's not going to be that different for the next fella. I'm going to use, in this case, the fact that the sine of y is 1/4, which means, again, it's an opposite over hypotenuse story. And I'm going to build a new triangle to represent that information. And it's going to be 1, it's going to be 4. And this is going to be my opposite. This will be my adjacent, and this will be my hypotenuse. And I'm going to find the third missing side again. This time it's not as pretty as the last time, but it's still Pythagoras, right? And if you take 16 and subtract 1, you get 15, and then you take the square root. Are you happy about where the square root of 15 is coming from? Now, once you've built that triangle, you can now use it to find, in this case, the cosine of y. It's the adjacent over the hypotenuse. And that is going to be square root of 15, yikes, over 4. And now I go and have a quick look. In this case, I should have called that y. In this case, y is in the first quadrant. Well, isn't the cosine of an angle in the first quadrant positive? So that stays put. It's just positive. So I now put this piece in, and I have a square root of 15 over 4. Right. 4 times that guy is 52. That times that guy gets you negative 12 square root of 15. Add 5 over 52. And if you stick them together, you probably would write the 5 first because it just looks better, over 52. And that big ugly fraction is the exact value of what you were looking for. Now, what they can do in this question, not a lot. Can you see that they're going to give you a sine and maybe a cosine the next time? Or a sine x is this and a tangent y is that? But you're still going to build triangles, find the third side, and that will allow you to get whatever it is you're trying to find. Now, if it's, I'm trying to find the cosine of x minus y, then I write down what its formula is, so I know the bits it's made from. And the bits it's made from, I find what they're equal to, and I'm done. Now, you don't know or memorize every single formula that you've got, but on Canvas, we've got that page and you'll find it there. If you print it, it's in front of you. You can just look for it and write it down. Right. Are we cool with that question?
Yeah.
Right. I'm just going to move on to the next section because we only have like an hour to do everything I want to cover. Is there anything you want me to go over that's still in this section that you had, it now came to you, oh yeah, I remember I couldn't do that?
11 and 7.2.
11 and 7.2, okay. I've got a copy of the questions, maybe not yours, but at least it'll be the same as yours, right? So 11 coming up. Ah, I recognize this one, or at least one like it. You've been given the sine of 9x plus the cosine of 9x, and you're being asked to express it in the terms of sine only. Oh, wait a minute. Let me look at that again.
I remember this one from earlier.
Yes. That question shouldn't have been there. I'll tell you what I would do, but I'm not going to do it. Do you know there a formula for adding two together? Let me show you what those look like. As soon as I leave here, I'm going to go in and kill that question. It involves something we never really covered, and it kind of sneaked in by mistake. Right. If you want to do the sine plus the sine, yeah, it's not on my list. It explains it. Okay. Well, the short answer is you don't need to know how to do 11, so I'm not going to spend any time on it. I thought I had the formula for it and I was going to show you it, but this formula here really belongs in 7.3. So that's another reason why it shouldn't be there. So note to self, kill 11. So it will disappear from your grade, so you won't even know it if you got it wrong. If you got it right, well done. Okay, can we move on to our next fella then? Right, okay. So, darn it. Well, things like that happen from time to time. Let's look at double and half angle. Let's start with the right in at the deep end. I'm going to do the hardest version, then if we've got time, we can go and do the earlier versions. So, suppose I tell you that the sine of x is 1/3
It's not
And
showing,
say again?
it's not showing your writing on my page.
Oh, that's because I forgot to stop the sharing. Thank you for telling me. Right, you should be able to see it now. Right, now, suppose I tell you the sine of x is 1/3 and x is in the second quadrant. And the question is, some more of these, find the exact value of the sine of 2x, the cosine of 2x, and the tangent of 2x. It's not unlike the ones we did, but in fact, in the ones we did, there was two angles, right? A sine x is this and a cosine y is that. But here there's only one guy, and somehow or other we're going to find the exact value of the double angles. These are called double angles. Well, separate that out. I'm going to start with the only piece of information that I've really got to work with, which is that. And I am going to say opposite over hypotenuse. Deja vu, right? Very similar. I'm going to build a right angle triangle. I'm going to call this angle here x. That's going to be my opposite, my adjacent, and my hypotenuse. My opposite is the top guy, 1. My hypotenuse is 3. And can you trust me that eventually the adjacent ends up being the square root of 8 using Pythagoras? This triangle is going to contain everything that we need to answer all 3 questions now. First one is the exact value of the sine of 2x. You go and look at the formula and it says 2 sine x cosine x. That's the double angle formula. We just tell you that's what it's equal to in terms of sines and cosines. Now that's going to be 2 times. Well, I know what the sine of x is. It's over here, so I'll just write it down. What I can now get is the cosine. Won't it be adjacent over hypotenuse? Is there something that I've overlooked in the cosine guy?
It's in quadrant 2.
So what is it, positive or negative?
Negative.
See how easy it is to lose the sign? X is in the second quadrant. Cosines in the second quadrant are negative. So any answer I get that's to do with a cosine should be a negative answer. Right? Now, tidying it up, which isn't much of a tidy up, there's a negative of 2, a square root of 8 over 9. Now it gets a little problematic. You might type that into your homework box, and get a correct and you're happy. That's great. I don't have a problem with that. But it might say wrong. Not because it's completely wrong, but it's just like it could be written better. In fact, the only bit that could be written better is the square root of 8. Square root of 8 can be written as somebody else, can't it? 2 root 2. Agreed? So negative 2 times 2 root 2, and that's going to get you negative 4 root 2 over 9. And that's the answer that you would do. Now, a couple of pointers here. I can imagine this being a test question. You put in this answer here, right, up there. And all I will get back is 0 out of 5, because it's not a very intelligent grader. It says, if you're right, I'll give you all the points, and if you're wrong, you're getting nothing, right? It doesn't give you partial credit. But if you send in your working, when I look at your working, I will look at that and I will say, hey, you're really right, for all intents and purposes, right? You just wrote it differently. And you get your 5 points back, or at least 4 points back if it's kind of almost right and it was just a sign that you missed out, right? Maybe you didn't put the negative in. But see, the homework is not intelligent enough to figure out little mistakes that people make So it just is, you're right or you're wrong, and that's it. And we like the shades of grey in between those two. So I'm just selling why we want to see homework, not why I want to say homework, why we want to see working when you do tests. Right. Now,
You're the first teacher ever who does that.
does what?
Lets it slide on not completely simplifying the root.
I guess I'm more generous, but that's fine. I'm not going to change I'm not going to change what I do because other people don't do it. In fact, wouldn't the world be a really boring place if we all did exactly the same thing? Yeah. It just wouldn't be fun. It wouldn't be fun if Ezra and Hannah all liked the same music, all ate the same food, all wanted to go to the same places on holiday. What a boring world that would be. Which means I'm going to have to tell you a joke now because that's just came into my head. Right? This one, at least no one gets killed. So that's a plus. This Canadian was walking down the street of his main street and he had a big crate of beer on his shoulder. And he's dead happy. He's walking down with this crate of beer. And his friends across the road from him waves at him and he says hi, and he says hi back. And his friend says, "What's that you've got on your shoulder?" And he looks at it and says, "Oh, it's a crate of beer for the wife." And his friend said, "That was a good swap."
Oh my god.
Okay, I get one hand clap. I'll take it. I got a couple of shaking heads. Okay, I got 2 hand claps. That's it. I'm quitting while I'm up. Okay, now, there is more to this question, but I don't want to spend too much time doing the details because it's really much more a process. If you wanted to find the cosine of 2x, you find the cosine of x squared, take away the sine of x squared, and then you get an answer. So you know you've got both of those already calculated. So you take the sine, the cosine squared, take away the sine. Now, if you wanted to find the tan of 2x, the simplest way to do it would be just to take the sine of 2x and divide it by the cosine of 2x. So I'm skipping these guys, but can you imagine you would go ahead and you could finish them yourself? The hard work is already kind of done when you create the triangle because it allows you to get any angle you want, right? Any sine or cosine of any angle that you've got. Here's a different version. I'm not doing the entire question. In fact, I'm doing very little of this question. Suppose they told you that the sine of x, the secant of x is 4, right? And x was in the 4th quadrant. And it's the same question. It's going to say, find the exact value of sine, the exact value of cosine, and the exact value of tangent. That's the killer. It's okay if you tell me what the sine is, because I can use SOHCAHTOA, right? But if you tell me a secant, I'm kind of stuck. Well, there's a little trick. If you know the secant is 4, isn't the cosine going to be its reciprocal, 1/4? Which means that guy is your adjacent, and that guy there is your hypotenuse. So if you imagine me drawing the triangle with x here, opposite, adjacent, hypotenuse, 1/4, and then square root of 15, right? And off you go and you do your question. So do you see that once you go over that first little hurdle, it's really no different than the one I just finished a minute ago. I got lots of nods on that. That's a good one. Is there any questions from this particular section? The homework questions from 7.3 before I start doing some more stuff from it.
Yeah.
Right, well, I got that 11, so I've got a note, kill, right? What else have we got?
I was working on 7.3, number 3, the lowering powers.
Okay, that we can look at. It's on this page here.
Yeah, I tried finding the videos and it just didn't really explain it to me that great, but I don't know.
I gotcha. Right, so let's take you through the question. So you've got cosine fourth power of x, and you're being asked to use the formulas for lowering powers to rewrite these expressions in terms of the first power of cosines. In other words, rewrite this guy so that there are only cosines in it. You can't have cosine squared, you can't have sines, you just got to have nothing but cosines. And that involves us using a formula that says this. That guy. So you go and look at the formula sheet, you use them, right? Now, if you read over the ebook, you'll see that being used, right? So you maybe get another example of this. So if you're looking at the cosine fourth x, I'm going to call that cosine squared x times cosine squared x. We okay with that? And now I'm going to replace the cosine with this ugly looking thing. And I'm going to replace the other cosine squared with the same ugly looking thing. You okay with that step? Now the next step is me tidying things up, but only a little bit. See these 2 darn a halves? Can I just call the thing a quarter? Are you okay with me just pulling out the 2 halves just to get them out of the way, because they're kind of mucking up my style here? Right. That wasn't a big deal. That was just me half times a half is a quarter and then pulling it out the road. What do you think I'm going to do with these 2 guys?
Boil them.
Exactly. And you're going to trust me on this. Does that seem reasonable? Eventually, that's what you'd get. Can you imagine it being foiled out? Now, we are so darn close to the end. Because I've got a quarter, I've got a 1, I've got 2 cosine of 2x, which is fine. And then I got this. And you might say, can't I use it? Nope, it's got a square in it. And the question says, I want an answer that don't have squares. So I'm going to have to figure a way of rewriting cos squared 2x so that it doesn't have cos squared 2x in it anymore, right? It's just cosines of some kind. And this bit is the bit that some people find a little bit weird. Do you know this formula up here that tells you what cos squared x is? And you just treat, you treat it like magic. Somebody tells me that's what it is, that's what I'm going to do. Do you know you can adapt this formula to get a formula for what cos squared, not cos squared x is, but cos squared 2x? And let's see what it would be. It'd be a half, 1 plus the cosine of something. Now, if cos squared x gets you cosine 2x, what do you think cos squared 2x is going to get you here?
4x.
And you have now done the little piece of magic that you need. That cos squared 2x is going to get replaced by this. And I'm just saving myself 1 line of working. Do you see that I've actually multiplied the half and the thing out? Now what's left? Well, I got a quarter. I get this guy and this guy, which I guess is what, 3 halves. I've got this fella. And right at the end, I've got this even uglier looking fella. Now that is just pure trig algebra, right? There's not a good, I can't say, oh guys, you're going to use this in engineering one day. You probably never use it in engineering. It's not there for that job. What it's there for is to try and get you comfortable with using trig functions and expressions and rearranging them in weird ways and different ways. Because there may come a time when you've got this really weird looking function that has all sorts of trig expressions in it, and you want to try and figure out, is there a better way to write it? Can I change it in some way? Can I make it easier? Sometimes these things here actually tell you stuff. You know that the 4x and the 2x here are telling me a little bit about the period. What that's saying is that this function is really made up of two different cosines with different periods, all interacting with each other. And that might give me some insight into what that sound wave is doing. Right? It's not just a tone, it's varying in relation to two different versions of cosine interacting with each other. Are we good? Right, that one is a killer. I totally agree, but it is going to stay because that one should stay because it's meant to be there. And the other question 11 is out of here. Are we good? Right, now I got 5 minutes or so to show you the last guy. So we're going to look at a half angle question. And it's going to look very simple. An example might be, find the exact value of 22.5 degrees. Now, you can't use the trick that we used earlier today. Do you know the one where you go to the unit circle and you find two guys that add up to that or two guys that subtract from that? Can you see that that ain't going to happen? Because there ain't a 0.5 anywhere, so how are you going to get a 0.5 out of it, right? So forget it. So we're going to have to use a new guy in town, and it's going to be the half angle formula. And I want to show you the guy. So here it goes, if it works at least. Oh, Darnton Smith, where are you? Okay, let me check this out. Okay, can you see the add and subtract formula here? Right, can you see this guy called number 7 half angle formula? Can you see that? Oh, perfect. Right. Oh, I shouldn't say that. We want, right, the sine or the cosine of that guy, right? 22.5 is not a question, right? So the fella that I'm going to use is this angle formula. The sine of a half x is plus or minus the square root of 1 take away cosine x.
Writing's not showing again.
Oh, okay, let's switch around. Right. So to find the exact value of sine of 22.5, I'm going to use this formula. I'm going to use the half angle formula for the sine because they asked me for a sine. If they wanted a cosine, I'd use the cosine x over 2. If they wanted the tan of it, I would use the tan x over 2. Right, so that's why I'm picking this one. Now, it's plus or minus the square root of 1 take away the cosine of somebody over 2. This fella here is who x over 2 is. So what does that make x?
45.
Do you notice now that everything on this side inside the square root is doable? We can get numbers for it. Right, I know what the cosine of 45 is, right? So let's see what it is. I'm writing the plus minus for a little while longer. The cosine of 45 is root 2 over 2 over 2. Happy about that? Now, that is never going to pass muster. I wouldn't accept that either, right? There are limits to what I accept. You can't have fractions with fractions in them. So I am going to make this look pretty. And I'm going to do a little trick, which is basically multiply by 1. And the special version of 1 I'm going to use is 2 over 2. So it's plus or minus the square root of 2 times 1 gets you 2. 2 times this guy gets you this fella. And 2 times 2 in the bottom gets you that. Are you happy about this? This thing now becomes that. Can you see what I did? Double everybody in the top, double everybody in the bottom. Now that answer is much better, but that's still not going to get you there. If you've got a square root of fraction, can't you take the square root of the top and bottom separated? So the top is that guy, and the bottom is 2. And that's as good as anybody's ever going to get. Now, I've been holding on to this plus and minus probably for far too long. I just wanted to forget about it for a while. Isn't 22.5 in the first quadrant? And isn't the sign in the first quadrant positive? So that means my answer is the plus version. But you know we don't write plus, right? We just don't write anything, and that implies positiveness. So when you type this into the box, that's your guy. Okay, now that's kind of at the end of today. It's been a long day for everyone. This is my 7th Zoom meeting today. Yeah, it's a long day. So it's been fun. I've told some really bad jokes, and I must admit that you lot are the most intelligent class I've got. I'm basing that on the fact that you laughed at more of my jokes than anyone else has. So that kind of proves it. The alternate to that is that you're the dumbest class I've got, and that's why you're laughing at my jokes. But I'm not going that way, because I think you are very highly intelligent and excellent sense of humour. And I should finish with one more joke then after I've buttered you up, right? One more?
Let's hear it.
Oh, you're not going to like this one. Right. The Polish army and the Russian army were fighting a war, having a big battle. And the Polish army ran out of bullets and ammunition and everything. And the only thing they had left were sticks of dynamite. So they all grabbed big chunks, big lumps of sticks of dynamite, and they charge at the Russians, and they start throwing the sticks of dynamite at them. And do you know what the Russians were doing? No? They were lighting them and throwing them back. Okay, have a nice weekend, everybody. You know the rules. If you have any issues, shoot me an email. I'll try and get to you. I have a life as you do, so don't expect immediate emails. I may be out shopping for starters. Just getting out of this house is a great thing, so take my dogs a walk. But I will try and talk to you and cover any issues. And we don't have a test this Sunday, so it's a little bit less stressful. But you do have to make sure you get all your homework done so that you get the homework part of your grade up to scratch. Plus, you want to be ready for your test, right? So you want to get practice at it as well. Okay, bye-bye, everyone. It's been fun.